All right, you may have heard of mainframe pen testing and exploitation, mainly from our next speaker. DEF CON, please give a welcome to the soldier of Fortran.
Wow, that was awesome. The other room cheered for me. That was great. Morning, everybody. I really appreciate y'all coming to a Sunday morning talk at DEF CON. Front row, I'm gonna need your help. I can't see anybody else. And if my hand starts to drop and you can't hear me anymore, can you guys just be like, hey? Thank you so much. All right, so for those who don't know, my name is Phil Young. I'm the director of, we'll just wait for them to calm down. I don't know what's going on over there. So I'm the director of mainframe pen testing at NetSpy. You might also know me by my other name, Soldier of Fortran. I was a mainframe hacker, like a 90s hacker kid. I was a mainframe security enthusiast before I started doing this professionally. I'm a terrible karaoke singer. And just so folks know, like I always felt like an outsider, especially even in this community. This is my third time speaking at DEF CON, and I still sometimes feel like an outsider. So if you feel like that, that's everybody feels like that. And I've been doing like professional mainframe pen testing for about 10 years. This was supposed to be a co-talk, but unfortunately my co-speaker is no longer with us. He had to go home to take care of his kid going to college, so he's not here. But still gonna talk about him. So he was a 90s hacker kid. He was also a mainframe security enthusiast. He loves show tunes. He's really good at reverse engineering things, probably the best reverse engineer I know, especially when it comes to mainframes. Dude's a friggin' genius. He's also been testing mainframes for 10 years. Now there's a third person in this photo who we didn't invite, but he's the OG mainframe hacker. And we wanted to make sure we shine a light on him as well. Before Chad and I came along, he was like the only mainframe hacker who was publicly talking about how to do like mainframe pen testing, right? At mainframe conferences, not places like DEF CON. We've been trying to get him to come to DEF CON for years. But I want to make sure we talked about him because he is the OG for mainframe hacking. Now, since Chad and I have been friends for the better part of 10 years, I need help with I'm a great coder, especially when it comes to assembly. And so I will oftentimes send my code to Chad so that he can help review the code because it doesn't work, right? And every time I send him a piece of code, he puts me on blast on Twitter first. Then he fixes it. Speaking of Chad, since Chad couldn't be here, what I did was I told him, hey, send me like 10 to 15 photos of yourself. Not telling him what they're gonna be for. And then I said, hey, I want you to give me quotes that I will put in the talk. Okay, so remember this slide. Look at the bottom where, and yes, I did write that. I hope it's enough, okay? And now when I sent Chad the deck and I said, hey, I want you to put inspirational quotes or technical quotes, but I mistakenly told him, I will read off whatever you put verbatim. So the first thing he sends me with respect to this slide is he said, it was not enough. So thanks, Chad, I appreciate you. This is not so bad. I can actually see a bunch more of you than I thought, so we're gonna try this out. Who here can tell me where the mainframe is in this picture? Don't be shy, you can just yell it out. The system, someone said system in the back. Can you be a little more specific? Where the tapes are, no. Yeah, this guy put his hand up, yes. The red box in the corner that says 360 on it, yeah, that's the mainframe, right? That is the mainframe. The reason it's called a mainframe is because it holds all the CPUs and memory, right? It is the main frame, that's where the word comes from, where you host all the CPU, all that stuff. The rest of this is just I/O, right? You've got your terminal, you've got your card reader, you've got a dude pressing buttons for some reason, right? But everything in that one thing, that's the mainframe. Now, today, in a modern data center, this is what the mainframe looks like. It's exactly the same. Thank you. The only difference is this is the mainframe. And now this one box, I promise you right now, there is a box exactly like this in some bank or some airline's data center, and it is processing thousands of transactions a minute right now. And it's doing it flawlessly, and it's the workhorse of the enterprise. And lots of enterprises still rely on this platforms. You have no idea how many articles come out. Mainframe's dead. Mainframe's going away. This company's moving off the mainframe. This other company's moving off the mainframe. There's so many announcements. This company's moving off the mainframe. There's never announcements. We successfully moved off the mainframe. Okay, they never do. Some CIO comes in, starts the process. They got about halfway, and that CIO quits. Right? That's usually the steps. But so many companies rely on this platform today. Right? You've got airlines rely on it. I mean, if you flew on any of the major airlines, a mainframe was processing your transactions. Every time you use your credit card or debit card, mainframes are involved in some capacity, right? Auto manufacturers, obviously banks, but even companies like UPS use mainframes. If it's older than, say, it's like a 50-year-old plus company, guaranteed they're using a mainframe, okay? Before we get too far into the talk, I need to talk about some terminology that's important for y'all. So, RACF is what's called a external security manager. So there's actually 3 of them, RACF, Top Secret, and ACF2. Now, it's called external security manager even though it runs on the mainframe as part of the operating system. But think of it like Active Directory if you could replace Active Directory with something else, right? Better or worse. It's the same concept, right? So the reason is the operating system itself doesn't really care. It just asks what's called the SAF router, and it says, hey, is this okay? And then the router knows which product to route it to. You can only run one at a time. So that's RACF. Now, RACF controls sort of all the security permissions on the mainframe. In RACF, there are user attributes called special and operations. Special and operations allows you to edit any file, to change any file, to give yourself whatever permissions you want in the rack. If you have system special, but not operations, you can give yourself operations, right? If you have operations, but not special, you can download the RACF database and crack all the passwords, right? So either or gives you complete control over the system. APF libraries are, imagine if you had a folder where you could put set UID, any program you put in there was automatically like set UID, right? Very similar concept, but you can get into essentially ring 0 so long as you put your binaries in there, right? That is the control that mainframes use. Basically, when you put a program in that folder, it is allowed to run in a supervisor state with the CPU. That's what it means. That's how they control how programs can run. Key 0 is this is all terminology you need to know. Key 0 is every page of memory has a key. Key 0, if your process is running in key 0, you can edit any location, any page of memory you want. Otherwise, the only other time that works is if your keys match, right? So if I'm in key 8 and the memory space is in key 8, then I'm allowed to edit that region of memory, but if not, I can't. Now, we would like to think that, these are all myths about mainframes, right? But when it comes to these myths, this is a slide that Chad gave a talk on 10 years ago. And even today, we keep hearing about these myths, right? It is crazy. Okay, so there's really 4 main attack paths on the mainframe. You get your network attacks, right? Normal network type attacks, right? Nmap works fine, all these things. On top of that, though, we have SNA networks. So that's a completely different type of network that runs. We have the file system, right? You'd be surprised. Sometimes on pen tests, I go in and I have like write access to 30,000 data sets, or read access to like sensitive company information, like 110,000 data sets. It's crazy. External security manager, that's the other attack path. That's where we go in and we look at, do I have access to this? Do I have access to that? And in fact, some of the things we're going to talk about today are because of misconfigurations in the external security manager. And lastly, what this bulk of this talk is about is ZOS Unix. And the reason we wanted to talk about ZOS Unix was because we used to joke that like Unix was the gateway drug to mainframe hacking because it's so familiar, right? It is such a familiar thing to you, especially if you use Linux. In fact, I have a pretty good view of the audience. Can I have a show of hands who's familiar with Linux? Right, like most of the audience, right? So that's good because it's very similar, but also a little bit different, right? So it's based on System V, right, or System 5, and it really didn't get built out until mid-90s, right? So the IBM operating system is called ZOS, right? So it runs ZOS, and inside ZOS, you run Linux, or you run Unix, sorry. It was developed in 1994. It wasn't really a core part of the operating system. It was based on like Unix from Bell, those kind of things. In 96, it obtained POSIX compliant, and it took over running TCP/IP for ZOS. Prior to that, it was all jobs and stuff, but instead they just built the TCP/IP implementation on Unix. They rebranded it in 98 to Unix System Services, and it continued to grow a little bit more. And then today, they rebranded it again to ZOS Unix. And for those curious, Linux was released in 91. So just a little timeline. Now, when it comes to Unix, again, it's like Linux. It's a little bit different. You only get two shells. bin sh, which sucks. bin tcsh, which sucks a little less, right? They're both not great, but that's all we get. Look, everyone here knows Linux. I'm not going to explain how file systems work in POSIX environments. You get file permissions, right? Regular file permissions. But here's where it gets a little funky. You can also have other permissions that you put into your ESM, right? Like recf. So you can have, say, I have read access to this file according to the file system, but when I try to read it, recf says no, that folder is only for admins, right? Where that gets challenging is sometimes you can mix those up and not do a great job. You access the Unix environment. There's a whole bunch of ways to access the Unix environment. You access it through the OMVS command in TSO. So I'm not gonna say, there's whole other talks about hacking in TSO, but like you just type OMVS and you get like a Unix prompt. SSH sessions, which is what we're gonna use for this talk, right? Because we're trying to demonstrate how you can do all of this in Unix. Or you can use JCL, you can use BPX bash, you can use Rex scripts, you can call it from C programs. There's all kinds of things you can do, assembly programs, right? I know Chad wrote a module for Metasploit that spawns a Unix shell using assembly. So you can call it all kinds of ways. What's interesting is you can also access data sets from within Unix using this super funky command, right? So you do like // then the name of the data set you want to interact with, and then you pipe it to that's where you're copying it to. It's frustrating because only a handful of commands support it, and it's not clear. So like, I know copy works. I know cat works because the client I was on wouldn't let you copy a data set. So I just catted it and piped it out, like redirected the output. grep does not support it for some reason. So it just sort of like depends on what IBM wanted to do. Now, again, if you're familiar with Linux, this should all be very familiar, right? Close enough, right? You've got normal commands, you've got your normal stuff going on here, you can cat files. The fact that it's POSIX compliant means you can do all the normal things you can do in a Unix environment, right? It's not some crazy thing going on. Okay, so here's the next Chad quote. I can see it on my screen here. I don't. Ask me about Vegas, Phil. That's it. So I'm not going to leave time for questions, just so you know. So good luck. All right. When we made this talk, we wanted it to sort of walk you through step by step how we do a pen test, right? Because there's lots of tools and stuff that exist now that we didn't have, like 10 years ago. And it's important to understand how we start, because like jumping in straight to the end sucks. So there's a whole bunch of tools that exist today. These didn't exist 10 years ago because Chad and I wrote them, right? So you have a tool called enum. That's a Rex script. So for those who don't know, Rex is a scripting language. Quick question, who here ever used an Amiga? Yeah, that's way more than I thought. So Amiga came with Rex. But Rex is a scripting language. It was created by IBM as a 10% project. But anyways, Rex runs in Unix natively, and so we write a bunch of our scripts in Rex. We also have another script called OMVS enum, and that script is based on linenum. I'll get to that script in a bit. We also have a couple of Java tools called file traversal and Zoshog. Those allow us to sort of map out the file system, like do we have read access? Are there passwords in them? And then we have another tool called port scan, which we'll talk about when we get to egress. All of this is freely available on my GitHub. So if you wanted to test them out or play with them, they're freely available, right? And if you have a keen eye, you may have saw there was a file called all.jcl. Getting things onto the mainframe during a pen test can be very challenging sometimes. Uploading multiple, if you have to upload one file, it's a pain. If you have to upload multiple files, it's a bigger pain. Companies, for some reason, try to limit your ability to upload. There's always a way around it, right? There's always a way around it. So what we do is we package everything up, all of those scripts into one JCL, and then it just runs by itself. It adds all those programs. Now, how do we get it to the mainframe? You can just use SCP. Problem is, SCP only supports binary file transfer. And I'm sure as you're reading the slide, you're kind of seeing why. Does anybody want to guess why that's a problem? Okay, yes, a hand up. You don't have to yell because there's yes, character encoding. So code pages. Our files written in ASCII or UTF-8, the mainframe speaks EBCDIC. So we have to convert it to EBCDIC. So that's what we do, and then we upload it, and it's all good. For the purposes of this talk, whenever you see the blue prompt, that's when we're in Linux. So we're doing something to prep. That's our staging. If you see this prompt, that means we're on the mainframe, okay? Now, let's take a look at enum. So this is that enum rec script. So what this script does is it pulls information from memory. So it does a really good job of accessing things from memory, because we have read access to a lot of memory space. And it dumps information out about the operating system, about the current running environment. And it's been built, it wasn't just me, there's other people that helped JT and other people who have helped build this. Some things in memory are not documented. And so we sort of reverse engineer those. And what's interesting about this program is sometimes you're limited. You can't list these things, but it exists in memory if you know where to look. So that's what this rec script does. This rec script pulls out all kinds. I use it on every single pen test. The next script we have, the next thing we have is OMVS enum. It is based on linenum, okay? But I had to rewrite it for TCSH. And then what we did is we added a whole bunch of mainframey type stuff to it. So you'll see us running it here in a second. And if you're wondering why it's going to be OMVS said here, you can come talk to me after. But we're going to run it. We're going to tell it to send it to a report. And what's going to happen is it's going to go through and dump all kinds of information, right? And you'll see some more mainframey stuff. So the stuff that's going to be in all caps here in a second, that's a list user command from RACF, right? So it dumps all kinds of information, and then we comb through it later. The other thing we always test for is egress busting. You would be surprised how often we're able to go directly from the mainframe behind, I have to go through 2 VPNs sometimes to even touch the mainframe, but we're able to go from the mainframe directly to AWS or some other cloud provider, right? It is crazy how often that works. And so, in fact, one of my clients, we did the test. I wrote it up saying, hey, you have thousands of ports are allowed to no egress filtering out to this AWS host. And they go, we haven't used that ISP for 10 years. We have no idea how this is routing, right? So anyway, it's not really that hard. We use a Java program. The reason it's written in Java is most mainframes come with Java, right? By default. Also, it allows us to control the timeout of the packets. And then we just do a port scan, essentially a SYN scan. And then on the Linux box, we run a tool called Egress Tester, which is a fork of Egress Buster. And you can see all the open ports. Okay, next picture of Chad. He wanted me to say that I sent him this hat after he told me he bought a boat. That's a true story, actually. He bought a boat, and I was like, you know what he needs is a dumb hat with hair, because he does not have hair. Okay, let's talk about some analysis. So now that we've done the enumeration, we've gone through the enumeration, let's look at some of the output. This is from enum.rex, okay? And the important bits that we pull out of that are the location of the RACF datasets and the fact that, and what hashing algorithm they're using, okay? RACF uses either DES for the hashing algorithm or KDF AES. John the Ripper and Hashcat both support cracking RACF databases. And if you have read access to either of those two data sets, it's trivial, especially since we know that KDF AES encryption is not enabled. It's trivial for us to crack every single password in that database. I think Chad was telling me a story where he downloaded the database, cracked it in maybe an afternoon, like 2-3 hours, had every single password for every single user. Okay, so if you do run a mainframe, please make sure you turn on KDF AES. Now, when we look at the OMVS enum output, we see there's a bunch of stuff here, right? We can sudo root without a password. And we'll talk about that in detail. Files that should not be world readable, like someone obviously chmodded some stuff 777. We can mount, we can mount data sets, right? Which you can normally do, but this one gives us more access than we should have. And this last one is we can issue the extattr plus a command. Now, the other tool we ran that gave us some interesting output was Zoshog. Zoshog is based on Trufflehog, and it uses regex to find secrets inside files in Unix. And when we ran it, obviously we found a password. All right, here's the next one. God, I hate this one. Ask Phil to pronounce Java and then wiki. Java wiki. I don't think I say it incorrectly. All right, next is privilege escalation. So now that we know what's wrong, right? We know there's some vulnerabilities on the system. We definitely have to demonstrate impact, especially when it comes to mainframe hacking. You have to show impact because not every time, I would say 99% of the time, my findings are an uphill battle with the mainframers, okay? I get so much pushback. You have to show like, no, actually this setting is very dangerous. Look what I did, okay? So let's talk about privilege escalation. Obviously the first one is the super easiest one. We found stored credentials, okay? So this could be lateral movement. 9 times out of 10, it's not. So, and I would love to say this is a rare thing that I've only found once. No, I have found this multiple times, okay? So, do not store password in files. Obviously, if you have to, make sure the permissions are correct, and make sure you test those permissions because maybe your ESM, like RACF, is overriding those permissions and everyone has read access to it. So this is an example. There's an actual example from a client. Obviously not, I rewrote it. It's not their work, but it's very similar. And we found a script like this in the user's home folder, and it was chmodded 777, obviously because it wasn't working until someone did that, right? And then all of a sudden it started working. It had user credentials in it. And so super, super easy hack, right? Guys, mainframe hacking is not hard. It's not that hard. We just SSH in with the username and password, right? Like this is not rocket science. Right? We type their username, we type their password, and then we get in. And the first thing you do once you connect is you make sure you know who you are, right? So, okay, I'm logged in as me. And then we have some fun. And then the next thing we do is we run the command list user, okay? Because that actually tells us what we can do. And if you'll notice, this user has special in operation. So at this point, it's game over. We can kind of do anything we want. And the pen test turns from a pen test to now an assessment because we can read everything. Oh, great. This one's finally one not about me. He wanted me to tell you that Mark, from that intro, drove his Aston Martin into a washed out area of a road and had to climb out the window and be rescued from the roof. I asked him for technical quotes or inspirational quotes, and this is what he gave me. Okay, the next one we're going to talk about is this one at the bottom, because I know none of you know what extattr plus a does. That is only on the mainframe command, and it's very important to understand. So, remember when we talked about APF authorized programs? So APF authorized programs are allowed to get into supervisor state. That's what they're allowed to do, right? And that comes with a bunch of different things. On the regular mainframe side, you have to put them in an APF authorized program library, otherwise known as a folder. On Unix, you can actually assign programs the extra attribute A, that makes it APF authorized, right? That's all that does. Okay, so the access to control that is bpx.file. I know it says extra, but it's file attr.apf. So read access to that profile in RACF lets you issue this command. Most people should not have access to do that. Now, why is it important to get APF authorized? I'm going to walk you through what happens when you log into the mainframe and why getting APF authorized and all this stuff is important, because it's the thing I didn't understand. So when you log in, the first thing the operating system does after you log in is like RACF copies a bunch of user information about you into memory, right? And it refers to that memory region. Think of this like your ID, like your ID in Linux, right? And if you can change your ID to something else, right? Similar concept. So it sits in memory. Problem is that memory region is locked under key 0. And user processes only run under key 8. So we cannot change this region of memory. If we could take over the mainframe, right? If there's a way for us to change our key to key 0, then what we do is we just replace this. It's called the ACEE. We replace our ACEE with whatever user we want that exists on the system. And now we can become someone else, preferably an admin. But how do we change our key to key 0? Well, luckily, there's an assembly macro called mode set, and we just change it to key 0. And then once we do that, to issue that macro, you must be APF authorized to issue that, right? So in Unix, if we use that ext-attr command, we can make it APF authorized. Now, what does that look like technically? Like, what does that look like in practice? So here is what it looks like in assembly. Any questions? We can move on? Great. So really, this is the command here. Oh, that's great. The boxes on my laptop worked. So this is their laptop problem. So mode set key 0, that's the command. If the program will abend if it's not APF authorized here, so that means crash, right? So once it gets past that, you're golden. The next thing we do is we issue what's called a rack route. So this is going to build that new ACEE for us. And if you'll see there where it says user ID equals user len, well, that's actually down here where we have the user ID that we want to assume the identity of. Okay, so all we do is we write this program up, then we put it into a file in Unix. We assemble it. So if you've ever used the assembler on Linux, it's the same thing, right? This very similar commands. Then we link it, right? Because we have to link it. And then we make it APF authorized, okay? So that's it. That's all the steps you have to take. And then here's a demo that we put together. It's gonna show Chad taking over my account, right? So he's trying to access a file. He's unable to access that file. He's going to run his APF authorized program, and now you can see he's become Phil, right? He's become my user ID, and now he's able to cat that file. It's a file I wrote for him especially because he is the coolest. I did not write that. This is a 100% Chad demo. All right, next picture of Chad. Take Phil to a karaoke bar and get him to do regulate. You won't be disappointed. You will be disappointed, I promise. Okay, let's look at the next one, sudo root. I know it says sudo root. There's not really a concept of root users on the mainframe, okay? So on the mainframe, we actually call it super user or UID 0, okay? The problem is, on Linux, if you get, root, like UID 0, it's game over for that box, right? You can do anything you want. You can change anything you want. The world's your oyster. That's not really true on the mainframe. Yes, you have UID 0 in Unix, but that doesn't convey anything outside of Unix. Like when you log in, that address space that we talked about earlier in key 0, even though you sue up to root, it doesn't change your actual user and address space in the rest of the mainframe. So here's an example. So here I am. My user ID is Phil. I type the su command. Notice I don't have to provide a password. So I type the su command. Now I'm a different user, theoretically, right? But when I do the recf command lu, I'm still me. But that's fine. There's a billion ways around this. This is just one dumb example. I'm sure if you're creative enough, you can find 1,000 different ways to do this. But the easiest thing for us is just to add an SSH key for an admin. So, and that's really easy. So we pick Mark, of course, and we make the .ssh folder for him. We then make the authorized key file for him, make sure the permissions are good on that file, and then we put our public key in there, right? And that's what it looks like. Everything's fine, everything's good. And then we just SSH in as them, right, with our private key that we generated ourselves. And then we're logged in as Mark. And if you look at Mark, Mark is special operations. So it's game over again. So I don't know if you're noticing a trend, but we have, like, our two goals is either to get special operations or APF authorized. Those are the two things. All right, next one. The lucky among you might get to play crafts with Phil later. Damn, I'm sad I'm missing that. Oh, thanks, Chad. Okay, next. This mount one. Okay, when you look at when you look at the mount points, if you've ever mounted an ISO in Linux, it's very similar, right? Think of it almost like volumes in a container, right? So you take the whole file system is based on data sets, right? And you mount those data sets into a location on the file system. That's all it is. Now, if we have update access to either of these two profiles, right? superuser.filesys.usermount or superuser.filesys.mount, what that means is we can mount a data set and preserve the APF bit and the set UID bits. If we have read access to either of those profiles, then those bits are ignored. But and if you saw in our output, we definitely did have access to superuser.filesys.usermount. So what we do is we create a payload on a mainframe we own, right? I have a mainframe at work. Chad has his own mainframe at his work. So we create a data set that that's going to be malicious. Then we create our programs. The ones you just saw, we can make them APF authorized in our own system, right? We can craft this payload. We unmount it. We package it up with some JCL. We transfer it to the target mainframe, and then we receive it and do all these things, and then we run our tools. So this is the JCL to mount that data set. It's very familiar to, like, the mount command, right? So we have, we're going to mount the hack the planet, and then we have a mount point that goes to /temp/hack the planet. And then when we look at the output, you can see here, this one maintain the set UID bit. So now we can sudo root, we'll get UID 0, bypass without having to do any of that fancy stuff, having access to bpx.superuser. And you notice there's programs here that are APF authorized. Even though we don't have the ability to do that on the target mainframe, because we could mount a file system, we could do that. Now from here, the demos are exactly the same as the other two demos, right? We can either modify people's home folders or, because we're APF authorized, become any user we want to become. Great. He's wanted to tell you that he grew up on a farm and the tractors all ran on COBOL. I highly doubt that, but all right, let's talk about buffer overflows on the mainframe. You know that slide earlier with Ralph, and it says you can't do buffer overflows on the mainframe? That's a myth that has been debunked multiple times, and I gave a talk last year at Share, Share's being the mainframe industry conference, where someone in the audience was like telling me, you can't do what you're telling us you can do. And I'm like, guy, the whole talk is about mainframe buffer overflows, and I'm teaching you how to do it. And he still wouldn't believe, right? So there's still this myth that you can't overflow buffers on the mainframe. It is so false. Anyways, lots of programs in Unix are written in C. C is not a memory-safe programming language, okay? And so if you have a C program and there's a buffer overflowable variable, and it's APF authorized, now we can execute APF authorized code because of this program, right? How do we find APF authorized programs? Oh boy, this red box is way off. So how do we find them? we use the -exta. This is a find command. And you can use find and then -exta, that's extra attribute A. That will show us all the APF authorized programs that exist on that LPAR. This is just one screenshot. It kept going forever. Am I saying that all these are vulnerable? Probably not. Probably a whole bunch of them are probably not vulnerable at all. But I know researchers who have found vulnerable programs that were APF authorized, okay? Unfortunately, we have like 10 minutes left. Getting into the complexities of writing a ZOS buffer overflow would take hours of content to get you to understand it. Fortunately for everyone here, there is hours of content available to you to learn this on your own. Jake LaBelle gave a great talk at DEF CON 30 on how to find and exploit ZOS buffer overflows and explain the memory layout and all that stuff. Don't take a picture yet. There's like 2 more things to go through. Chad gave a talk. In fact, if he was here on stage, this would have been our 10-year anniversary giving co-talks. We gave a talk 10 years ago. And part of that talk, he explained how he could do buffer overflows in ZOS Unix. And Jake and I, DEF CON 30, we taught a class on mainframe buffer overflows. And that class is freely available. You go to, if there's a Docker container, you run it, and it walks you through step by step how to do a mainframe buffer overflow so that you can generate something that looks like this. Okay, did anyone get their picture? I saw some people trying to take pictures. You want me to go back? Everyone's good? All right. So this is doing like the stuff we were talking about earlier, right? The rack routes and all that. So this is machine code that we're going to use to overflow the buffer. So that's shell code. We don't call it shell code, but it's shell code. All right, here we go. Here's the next one. He wanted me to say that Phil and I had a tradition of going to piano bar after every evil mainframe training. Ask him about the fish bowls. Be my guest. It's fine. Okay, let's talk about some honorable mentions that I see on pen tests. So remember how we mentioned that you can enhance your security by letting the ESM have like more security on top of the file system, right? I have been on systems where that was done improperly, and while it looked like I didn't have read access to some folders or files, I could read every single file on the entire ZOS Unix because it was not done. It was not secured properly. This one's fun. There was a shell script in bin that was world writable. That was chmodded 777. So it was in /etc/profile. So every time someone logged in, it ran. So I just modified it a little bit, and then when a user that was special logged in, it then made my account special. This one is not really an exploit or anything like that, but this happened too many times. I want to let you know about it. Please don't make your logs that go to the sim world readable or writable, because I've been on like 2 or 3 mainframes now where the staging folder in Unix and the files in that folder are world writable. Okay, so please don't do that. Last one is I was pen testing a mainframe. I couldn't access much in ZOS Unix, but they had a web app that had an LFI vulnerability, a local file include, and then I could read a whole bunch of files. So I was like, I could see where they were, but I couldn't read them, but the web app could. Now, I would be remiss if I didn't tell you how to prevent and detect these, right? I hate watching talks at DEF CON. It's like, oh my God, that's terrible. What do we do about it? Too bad. That's not what I'm here for. That is what I'm here for. I'm going to tell you how you prevent it and how you detect it. So first, prevention, right? Review your file permissions. You can just run a find command to find everything that's been chmodded 777, okay? Please check every single pen test I do, I have file permission findings. Please check your file permissions. Review and control access to these profiles in your ESM. They are the same profiles. Doesn't matter if you're on ACF2, top secret, RecF. Make sure access to these profiles is limited. In fact, I would argue no one needs to have this access unless it's a break glass account, right? Test your file permissions. Even though the file permissions look correct, there might be something in your ESM that's overriding those permissions. Okay, now let's talk about detection. Monitor, we say log, monitor your SMF messages. SMF is the logging facility for ZOS. Someone who's using bpx.superuser. So every time you type su, the operating system goes and says, hey, does this user have bpx.superuser? And then it says yes, right? Or it says no, right? If it says yes, you should probably be monitoring for that. Who's using it? Why are they using it? Same with the bpx.file attr.apf. No one should really have that. That should be something that you're installing updates or patches, but no one should just have that as a blanket access right. If someone is using it, it should be traceable back to a request or a ticket of some sort. And then obviously the mount commands, again, users shouldn't be mounting things as a super user. That should be all done by the operating system during startup, right? Like, no one should really have that access unless it's like a break glass situation. Detect large number of unauthorized attempts to access files. You'll understand how, like, it will log every failure when I run my OMVS enum script. It's looking for files and it'll tell you like access denied, access denied. Those all get logged somewhere, right? No one has ever come to me after a pen test and be like, hey, did you try to access like 30,000 files? Never, because no one's monitoring it. Detect multiple, obviously, look, if you're trying to see someone do connections out to AWS on your like firewalls and whatnot from the mainframe, that's probably a good indicator of compromise, right? Something to check for. Because the mainframe should have very well understood and well-known patterns of connectivity. There should be nothing exciting happening there. And then we're going to talk about the Unix file system auditing. This is like very unique to z/OS Unix. So when we run z/OS Unix, and when we're running z/OS Unix, and we issue ls with a capital W, we get this new column here, right? And this column is the audit column, right? That's what's happening here. So let's take a closer look. It's split up into two parts. The first part is user controlled. So if you have read, write, execute access to that file, you can modify those settings. The other three are admin controlled. So if an admin wants to set, so you could set it as like, hey, I don't want any audit records for this file, but your admin could set something that says, hey, I want to know anytime someone changes that file, right? And you as the user you cannot change it back. This is the default. So F for fail, and then no admin control. This is the default for every file created in z/OS Unix. If you list any file, that's the default. And the way it's broken down is very Unixy, read, write, execute. So if I try to read the file and it fails, it's going to write an SMF record. If I try to write the file and it fails, it's going to write. And if I try to execute, it's going to do that. Now, much like you can chmodify, you can chaudit a file. And so you use the chaudit command. And what we're going to do is we're going to say, I want success and failures. And now when we run that same command, you can see now they say all. So now I have all, anytime someone accesses that file, anytime someone writes that file. Now, this is a little extreme. Don't do this for every file, but you should know what files are critical to your mainframe. And you should know, hey, if someone makes a change to this file, we want to know about it, right? Things in /etc. Probably a good idea to know who's mucking around in /etc. Right? Okay. So with that, we're nearing the end of the presentation. I have to do some shout outs to, because I'm up here because of the efforts of a lot of other people. So first I want to say thank you to DEF CON for having me come here. I really appreciate you all. The mainframe hacker community, when Chad and I started doing this, the mainframe hacker community was 2 people, Chad and I, okay? Over time, that has grown. The third member was Henry, Wizard of Zos. And over time that has grown, so now there's like a good 24 of us, and we chat, and we all know each other, and we share ideas and whatnot. So I have huge thanks for them. The Moshix Discord, so if you're not a mainframe person and you're like, oh man, this is interesting, go watch Moshix's videos, go to the Discord, it's super welcoming, it's not very, do not go to mainframe forums, it is the most adversarial place on earth. Go to the Moshix Discord, it's super chill, everyone's there to help. The mainframe cybersecurity community, I went to Share being the mainframe industry conference, and I was so nervous the first time because I thought they hated me and all these things. In fact, a major vendor threatened to pull out if I spoke at that conference kind of thing. But the Mainframe cybersecurity community at that conference is the most welcoming and amazing community there. So huge shout out to them. And I do want to thank my co-speaker, Chad, for helping me out with this talk. And I do really wish he was here. If you want to reach out to me in any capacity, if you have questions, I'm always interested if people have ideas or questions. I will take any pull request within reason. So if you want to look at my code, it's not good, but it works, right? So if you want to take a look and reach out to me, that's totally fine. And I'm going to leave the talk with the last quote from Chad. So remember when I said there were 2 members to the Mainframe Hacker Society, and then Wizard of Zos joined us? That's Wizard of Zos in the middle there. So that's, it's a tight-knit group of people. So this is what he wrote for me. I'm going to try to get through it because it's a little long, and I love it. So dear Phil, in all seriousness, I am really sad I couldn't be here, even though I know that you absolutely kicked ass, and you do not need me here to do so. You've been one of my best friends and partners in crime for a decade. I would not be here where I am without your friendship and knowledge and willingness to put up with my shit. I cannot wait to see what the next decade of hacking the Gibson with you brings. And with that, I want to thank everyone for being here, and that's the end of my talk. Yeah, I heard that.